Okay, here we are. We're looking at section 6.1. We're looking at the basics of exponents. Trying to move this stuff out of the way. And I thought this was kind of cute. I didn't make it up. Exponents are number. You got to know a little bit about exponents to make this kind of funny. 3,924. Okay, that one seemed really long. 3,924 to the 0 power. Which we all know right now is 1, right? Based on class information. All right, if you missed class, and the day we kind of went through these rules, this information has already been covered. I'm going to highlight some of this up here. All of this, if you don't have it in your notes already, needs to get in your notes. Oh, yeah. And I should have another rule right here, and then this rule right here.
Talley, please dial 2023.
Basically, that's what it boils down to. Okay, I just need to show you some much more challenging ones so we kind of up our game a little bit. Here we go. We're going to simplify here. Negative 3x squared y times 5x cubed y to the 5th. Take these numbers times each other first. Negative 15. X squared times x to the 3rd. Well, if I write that off to the side, when I'm multiplying with like bases, I add my exponents. So that gives me x to the 5th power. Then I look at my y's. I've got a y times y to the 5th. Don't forget this actually has an exponent of 1. And if that's the case, then I have y to the 6th power because I'm going to add my exponents when I'm multiplying with like bases. All right, simplify this one. I'm going to take my numbers. 3, I don't have a number in that one, I guess 1 technically. 3 times negative 2 is negative 6. I've got an a to the 5th and an a to the negative 4th. When multiplying with like bases, add your exponents. 5 plus negative 4 is 1. So you can write 1 if you want, or you can just write a. You don't have to have to the 1st power. Then I see I have a b here. I don't multiply that by anything, so I have b to the 3rd power. And then I have a c to the negative 2nd power. But wait, you can never leave a negative exponent in your answer. So if that's the case, you have negative 6a b to the 3rd over c to the 2nd. Okay, because anytime you have a negative exponent, so if it was just this alone, you would write it 1 over c squared. Well, all of this stuff is in the top. It keeps a positive exponent. All right, the third one here. Negative 2 times negative 5 is 10. Notice how we do regular multiplication. We add exponents when we're multiplying with like bases. We never add our like coefficients. Oh, a to the 3rd times a. Once again, you have to think in your mind, there's an actual a here. There's 1a. So when I'm multiplying with like bases, I add my exponents. And I've got a b times a b to the 4th. Okay, once again, there's actually a b to the 1st. So when I multiply with like bases, I add my exponents. I get b to the 5th. All right, moving on to examples B. All right, got 3 here. Actually, in all of these, we should be assuming that s is not equal to 0 because we can't divide by 0. All right, so what do? When we're dividing with like bases, we subtract our exponents. We take 3 minus 7. And because of that, you're taking the top minus the bottom. Always the top minus the bottom. So this ends up being x to the negative 4th. But we can never leave a negative exponent in our answer. So I'm going to have 1 over x to the 4th power. You flip it. Same with this one. When you're dividing with like bases, you subtract. So you're going to have 2 minus 10. Top number minus bottom number. And I should say top exponent minus the bottom exponent. All right, so you have s to the negative 8th power. Oh yeah, no negative exponents in your answer. So you flip it. 1 over s to the 8th. All right, simplify this one. I have students who think with this that for some reason we're going to do the same as this, and we do not. This is different. If I gave you 9 over 3 in a math minute, you would just reduce it. You say, hey, 9 over 3 is just 3. So then you get 3. All right? Then you have this. These are exponents. So when you have like bases, you subtract your exponents. So you have x to the 2 minus 7, which is negative 5. Oh, but you can't leave a negative exponent. Here's another catchy thing here. I got lots of kids who wants to flip the whole thing. This -5 only applies to this x, just that x and only that x. It doesn't apply to the 3. So the 3 stays where it is, if I can write it, that is, and the x to the -5 flips to the denominator and becomes x to the +5. I don't know if I said negative to begin with, but that's what your answer should be. Notice how the 3 stayed where it was. That's one of those catchy things, it seems like, with all of my students. All right, example C. I'm going to take 4. Oh, all I have is a 4 there. I've got x to the -2 times x to the 1st. Multiply with like basis, add your exponents. -2 plus 1 is -1. Okay? Y to the -3rd is coming out of this. Okay, nobody to condense that with, it just ends up being y to the -3rd. Okay, now with that said, I got negative exponents. This 4 has an exponent. It has an exponent of 1. It is not going to flip. Everything else will flip out. All right, so x moves to the denominator. Y to the -3rd comes to the denominator as y to the +3rd power. Notice again how that 4 stays there. All right, this one right here. I've got a 2 times -7, -14. Those are not exponents, so I don't add them. They're regular numbers that are being multiplied. Then I have x. When I add these exponents, -3 and 5 is a 2. And -3, -6. When multiplying with like bases, I add those, I get a -9. Here's another common mistake. I have kids who think that, oh my gosh, I got -14, I gotta flip it. You only flip negative exponents. This -14 has an exponent of 1. It will stay where it is. All right, x squared has a positive exponent. It stays. Y to the -9th flips to the denominator and becomes y to the 9th. All right, next one down here. Once again, I gotta point out, I just gotta go back and say -14 does not flip. Okay, -3 times -2 is +6. Y to the second, x to the second, x to the -5th. Multiply with like bases, add your exponents. So I'm adding them together, get -3. Y to the 4th and y. Well, this is actually a y to the 1st. When you add the exponents, you get y to the 5th. Okay, once again, the same occurrence is happening. 6 does not get flipped. Y to the 5th does not get flipped. X to the -3rd does. It comes to the denominator and becomes x to the 3rd. Okay, examples D. Here we go. Power to a power, multiply. This is to a power and this is to another power. So I have to multiply those. I have x to the 15th. Similar thing here. Everything in here gets to go to the 5th power. So I have -2 goes to the 5th power. I have a to the 5th power. I have b to the 2nd to the 5th power. So if I have power to a power, I multiply, I have a 10th power. Okay, this right here is like saying -2 times -2 times -2 times -2 times -2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Now, will that be positive or negative? It becomes -32. And then I have a to the 5th, and I still have a b to the 10th. And there's no other math that goes on with that. This does not flip because it's a negative number. We only flip negative exponents. So -32 stays on top. All right, and then on this one, everything here inside the parentheses is going to the 3rd power. So I have -3. I guess I should write that in parentheses to the 3rd power. I have x to the 2nd to the 3rd power. Power to a power, multiply. And once again, I have a y down here. We don't want to leave him out. He gets multiplied to the 3rd power as well. So 3 times 3 is 9. So now I have -3 times -3 times -3. Well, -3 times -3 is 9. But then I take it times -3 at -27. X to the 6th over y to the 9th. Okay. Examples E. All right, everything in here goes to the 3rd power. So I have -3 to the third power. I have c to the 6th power. How'd I get that? Take 2 times 3. Then I take d to the 15th power. Okay? Negative 3 to the third power we just did. Negative 27, c to the 6th, d to the 15th. All right, all done with that one. All right, here we go. Negative 2 goes to the third power. We have a, oh, look at this. Woo! 3n to the third power. Power to a power, multiply. So I have a to the 9n over a, this 2n gets to go to the third power. Well, 2n times 3 is 6n. And then I have b to the 5th to the third power. Power to a power, multiply. So I have b to the 15th. All right, let's start simplifying here. All right, negative 2 times negative 2 times negative 2, I believe, is negative 8. A to the 9n over a to the 6n times b to the 15th. This is where it could easily get caught. You're like, good enough, I figured out negative 8. Yeah, I'm doing good, Mrs. Talley. The only thing is, I see an a here, I see an a here. If you've got a's in 2 places, you have not simplified. It doesn't matter if they're top and bottom or any other location. When you are dividing with like bases, you subtract your exponents. So I need to take 9n minus 6n, which is 3n. So I actually have negative 8, a to the 3n, and that b to the 15th stays in the denominator. All right, let's do it again. Negative 3 to the 5th power. And then I have a 5y to the 5th power is 25y. Because I take power to a power and multiply. Am I going to say that a lot? Yes, so it'll be stuck in your head. A to the 6y to the 5th power. So that's a to the 30y power. And then b to the 20th. Okay, negative 3 times negative 3 times negative 3 times negative 3 times negative 3. Actually, I don't think I know that off the top of my head. 81 times 3, because 3 to the 4th power is 81. If you need a calculator, go for it, because that's what I'm doing. Oh, 243. So I have a negative 243. I have a to the 25y over a to the 30y, b to the 20th. All right, and then once again, I just want to highlight, and this is where your eyes, you've got to do your own highlighting here. I've got a's both places. So this negative 243 is going to stay. I have 25y minus 30y. So that's actually a to the negative 5y over b to the 20th. Okay, but that's not it, because now I have a negative exponent. And if I have a negative exponent, I got to flip it and give it a positive exponent. So negative 243 over a to the 5y, b to the 20th. And that's it. That's all I've got for you on that particular one, and that's all I've got for now. We're going to see some challenging ones over these, and it's almost like you have to deal with every problem as individual pieces. Look at the individual letters. Okay.